Hello everyone, hope all of you have seen those 3 episodes on polynomial what I have already uploaded. This session I will be discussing synthetic division and its application. What is synthetic division? Division you are doing from class 7-8 level. Obviously in polynomial division means you will divide a polynomial by another polynomial. But today's class, what I am going to tell you, there we will not divide the polynomial direct by another polynomial. Instead, I will take the coefficients of the higher degree polynomial and then we will divide by a binomial. Binomial means it is of the form ax plus b, it has a factor, one factor. And this shortcut is a traditional long division and is particularly useful when divisor is a linear factor. This process involves using only the coefficients of the polynomial and performing basic arithmetic operations. What are the steps I am going to tell you? Little bit I have discussed in the first episode on polynomial, but this session I will tell you in details will solve all types of problems which is based on synthetic polynomial. Like if you want to express a say 10th degree polynomial in terms of a first degree polynomial, how to do it? We can do it beautifully by using synthetic division. There you will write all the coefficients of the dividend polynomial in a row and 0 of the divisor you will write at the left and then bring down the leading coefficient to the bottom row. Multiply the 0 of the divisor by the value. Okay, wait. Let me take one suitable example. Before I do a problem, I just tell you what I was going to say so far. That steps for synthetic division. Write the coefficients of the dividend polynomial. Dividend means the polynomial which you are going to divide by another one. Write the 0 of the divisor, x minus c, it has 0, x equal to c. That will write at the left. Bring down the leading coefficient to the bottom row. Multiply the 0 of the divisor by the value just written below the line and write the result under the next coefficient. Add the values in the column and write the result below the line. Repeat the process until all coefficients have been used. Final row gives the coefficient of the quotient polynomial and the last value is the remainder. So, initially we will do it for first degree polynomial. Let's see with this example what is going to happen. We are about to divide 2x cubed minus 6x squared plus 2x minus 1 by x minus 3. What are the coefficients here? X cubed, the leading term, it has coefficient 2. This one minus 6, this one 2, this is minus 1. We have written in the row. And 0 of this polynomial is x equal to 3, that we have written on the left side. Then what you are doing? You can divide once only, no? That with x minus 3, that if you divide, then what is the quotient? Then you will find. What we will do there first? This 2 is the leading coefficient, it will come down automatically. Okay? Then what you are doing? Multiplying this 2 by 3, it is coming 6. Adding these two together, it is coming 0. Then 3 into 0 is 0. Then adding 0 and 2, it is 2. Then 3 into 2, this is 6. 6 minus 1, 5. This 5 is going to be the remainder. This is the remainder. Then what is the quotient over there? That quotient going to be 2x square plus 0x plus 2. So far in this calculation, I have not used any variable, just taken the coefficient and the 0 on the left, and then we have divided successfully. So on dividing this cubic polynomial by x minus 3, the quotient is this and the remainder is going to be 5. Okay. Now look at this sum carefully. We are going to divide this polynomial by the first degree polynomial, x minus 2. Today's class I will be discussing dividing a polynomial by first degree only. Later on, if required, I will show you how to tackle this kind of division with the quadratic also. So what will be the first step? You write all the coefficients: 1, minus 3, 5, minus 1, 2. Then 2 you write here. Okay. The leading coefficient automatically will come here. Then multiply 2 by 1. It is 2. Minus 3 plus 2 is minus 1. 2 into minus 1 is minus 2. Then it is coming 3. 2 into 3, that is 6. 6 minus 1, 5. 2 into 5, 10. It is 12. Now this term going to be the remainder, and the quotient qx going to be, this is x cube, 1 into x cube minus 1 into x squared, 3 into x plus 5. Alright. So quotient and remainder we can get very fast, easily, if we remember this synthetic division method. Now I am going to show you one example where I would like to express a polynomial. Say I am taking fourth degree only, I am writing here, in terms of a first degree polynomial. So our question is going to be like this: express x to the power 4 minus x cube 2x square minus 3x plus 1 as a polynomial in, see, this one is a fourth degree polynomial, and you are going to express this as a polynomial in x minus 3. This is a polynomial in x, but we want the polynomial in terms of x minus 3. I mean, polynomial will remain the same, but that all those terms we want to express in the form x minus 3. I am starting this manner. Let x to the power 4 minus x cube 2x square minus 3x plus 1 equal to a0 x minus 3 to the power 4 a1 x minus 3 cube a2 x minus 3 whole square a3 x minus 3 plus a4. This time, repeated application of synthetic division is required. What we'll do here first? We'll be writing all the coefficients of this given polynomial. 1, minus 1, 2, minus 3, 1. Then you are dividing by what? This polynomial vanishes when x equal to 3. You'll be dividing by 3. Okay? So without hesitation, this one will come here. 3 into 1 is 3. This is 2. 3 into 2 is 6. 6 plus 2, 8. 3 into 8, 24. And this is 21. 3 into 21 is 63. So this is going to be 64. A4 equal to 64. Now what to do? I told you repeated application of synthetic division is required here. We are going to divide this quotient and remainder you can write easily. But here my aim is different. I want to express in terms of a polynomial. The absolute term a4 I got here. Now I will try to get a3. How to? Again apply the method here for this polynomial. I mean whose coefficients are 1, 2, 8 and 21. First you take 1 down. 3 into 1 is 3. 3 plus 2, 5. 3 into 5, 15. 15 plus 8, 23. 3 into 23 is 69. This is going to be 90. Okay? Now what? This 90 stands for what? This 90 stands for A3. This was A4 and we got A3. Then apply synthetic division again. This 1 you take down. 1 into 3 is 3. This is 8. 24 and then finally 47. This 47 stands for what? That coefficient. That is A2. This is A2 only. Now again you apply synthetic division. 1 come here. 3 into 1, 3 and this is 11. So this is going to be A1. Okay? And this term, the last one will be considered as A0. This is your A0. So therefore, you can write x4 minus x cubed plus 2x squared 3x plus 1 equal to A0 you got 1. 1 into x minus 3 to the power 4 plus 1 into x minus 3 cube 47 x minus 3 whole square (90) x minus 3 plus 64. Got it? So this way we can express a polynomial in terms of another polynomial. But today's restriction for the first degree polynomial only. And this is a fantastic method, you should agree, where we can express a polynomial in terms of a first degree polynomial by using synthetic division easily. Other methods will not be very easy for you. That is known comparison method. And division of polynomial also can be done with the help of synthetic division nicely if polynomial, the divisor is going to be of this form ax plus b. Okay? It will take more time if you use factor theorem or remainder theorem. But here, this is very easy, I say that. Suppose I am taking the example here, no theory. Theory is just that only, what I told you. Find the quotient and the remainder find the quotient and the remainder when 2x minus 3 divides 2x4 minus 6x cubed plus 7x square minus 5x plus 1. Okay? We have to write the quotient and remainder when you divide this thing by this thing. This fourth degree by the first degree. How to do? I am showing you. Let you write 2x4 minus 6x cubed. First we are writing that remainder theorem only. 5x plus 1 equal to, just to understand the process, 2x minus 3 qx plus r. This you write as 2 into x minus 3 by 2 into qx plus r. Or you can write x minus 3 by 2 into 2qx plus r. Okay? Now 2qx is a polynomial and you are obviously going to divide this polynomial by x minus 3 by 2. What is the process? That I told you. What you have to do there? You write all the coefficients of this polynomial in a row. 2 minus 6, 7 minus 5, 1. And divide by x minus 3 by 2. So you take 3 by 2 here and then this 2 will come down. There is no disturbance on it. The first term I told you earlier also. Now multiply 3 by 2 by 2. It is going to be 3. Result is just on addition minus 3. Then minus 3 into 3 by 2 minus 9 by 2. 14 minus 9 by 2 is 5 by 2. Then 3 by 2 into 5 by 2 is 15 by 4. This is minus 5 by 4. Minus 5 by 4 and 3 by 2 minus 15 by 8. So there will be minus 7 by 8. Clear? I hope this step you have understood. Now, if you have divided by x minus 3 by 2, what is the quotient over there? That quotient going to be, 2qx. What is the quotient here? That is 2qx. So you will be writing 2qx only. 2qx is what? This will go with x cube. 2x cube, 3x square, 5 by 2x minus 5 by 2. And remainder going to be what? That remainder will be equal to minus 7 by 8. Clear? So what is going to be the qx, the quotient? This is a very clear-cut method. I think none of you have any problem with this. 5 by 2, no, it will be 5 by 4. 5 by 4 into x minus 5 by 8. Clear? Hope you have understood this synthetic division method. You can practice it somewhere. expressing a polynomial in terms of another polynomial is required. I can give you some time to solve it, then I'll show you finally. Today's class will be devoted to this method only. I am not going to discuss anything else. So I'll be writing a problem for you. Just write express three x cube minus 4x square plus 5x plus c in terms of the binomial x plus 1. This you express in terms of the polynomial x plus 1. You try for a few minutes, then I'll do. Follow the same method again, so that you write 3. I hope you all have started. Just check the answer with me. This x plus 1 vanishes for minus 1. So take minus 1 here. Now 3 will come down. Minus 1 into 3 minus 3. This is going to be minus 7. This minus 1 minus 7 is 7. That is 12. Minus 12, because you have multiplied by minus 1, it is going to be minus 6. Clear? So, it will be like this, where this minus 6 going to be what? This minus 6 is going to be the absolute term. What is that? It means this is a cubic polynomial. You are going to express this polynomial in powers of x plus 1. So you have assumed that let 3x cube minus 4x square 5x plus 6 equal to a0 x plus 1 cube a1 x plus 1 whole square, then a2 x plus 1 plus a3. That a3 we got here. Then repeat the process the way I did previous one. You take it down here, just 3 into minus 1 minus 3, and then it is minus 10. Minus 10 into minus 1 is 10 only, 22. Alright. Now, this is going to be, this one going to be the coefficient a2. Isn't it? Now what to do? You repeat the process for this polynomial, that minus this 3 will come out, minus 1 into 3 is, so it is minus 13. It is going to be like this. This is nothing but a0, this is a1, this one a2, and this one a3. Therefore, this is going to be equal to a0. a0 means what? That is 3 we got earlier. 3 x plus 1 cube minus 13 x plus 1 whole square plus 22 x plus 1 and minus 6 is the absolute term. Happy to share these 3 sums with you so that you can solve and share your answer in the description box or send it to my WhatsApp number. I'll happily check your calculation and then send you the response. Okay? my WhatsApp number is 28 working here also. Okay. So first one is quotient and remainder finding when divided by x plus 1. Second one just synthetic division to divide, same question basically. And perform synthetic division by x minus 4. Find the quotient and remainder. Learn the method and should practice where you can express a polynomial in terms of a first degree polynomial. So before I start theory of equation, polynomial, these 4 episodes I think will be of great help to start theory of equation. Next episode I am coming with the theory of equation, another. I might do one class on polynomial functional equation. That is a very challenging topic for ICI-CMI mathematics. Okay, so I'll decide and then I'll share with you the link. Thank you.